Okay, today we want to start looking at scientific notation to review for the test later this week. So if you remember back, we have two forms. We have standard form and we have scientific notation form. If we have numbers written in this form, 37,120, this is in standard form. We want to be able to convert from standard to scientific notation. Scientific notation means we can write any number between 1 and 10 times by 10 raised to some power. So we do that by looking in the whole number, and the whole number, the decimal, is always located at the end. We need to move this decimal either to the right or to the left to make this number fit between 1 and 10. So if you remember, we definitely want to go to the left here. And if we go over 1 time, that's just going to give us 3712. Decimal 0. That's still too big, right? So to save time, we know we need to move this decimal all the way over between the 3 and the 7. So if we get 3.712, this number is now between 1 and 10. 3.7 says between 1 and 10. Okay, so there's the first part, 3.712 times by 10 raised to some power. And we get that power by how far do we move the decimal. We move that decimal 1, 2, 3, 4 times. So scientific notation is 3.712 times 10 to the 4th. If we have the number 897 and we want to put this into scientific notation, once again the decimal and the whole numbers at the end, we need to make this number fit between 1 and 10, so we're going to move this decimal between the 8 and the 9. That gives us 8.97 times 10, and we moved it 2 times, so the power of 2. Okay. If we had situations where it was 0.0045, this number does not sit between 1 and 10 either. This is in standard form as well. This number is too small. So the decimal is not located at the end, the decimal is in the front. So if we move the decimal to the left, that's not going to help us. We need to move this decimal to the right. So if we move this decimal over between the 4 and the 5, we get 4.5 times 10 to some power again. But this is where we got to be careful. If you remember, we talked about in class, if we're making the number is small and we're going this way, it's going to be a negative exponent. So it is 4.5 times 10 to the negative third. If the number was bigger than 10, it was a positive exponent. If the number is small, smaller than 1, then it's a negative exponent. Okay, here's one of the ones in class that some people struggled with. So we had 0.0006. So right now the number is too small, so we need to move that decimal to the right. But be careful. I have some people in class that would just move it to here, and we just get 0.6. Well, once again, scientific notation is going to be between 1 and 10. That's not big enough, so that is incorrect. If it was 0.0006, that decimal needs to move from there clear behind the 6. And so technically you're getting 6 decimal, nothing. So 6 is between 1 and 10. So 6 times 10 raised to the negative 4th power. We moved it 4 times to the right. So once again, if it's a big number, positive exponent, small number, negative exponent. Okay, that's standard form of scientific notation. We also looked at going the other direction. So if I had a number 3.7 times 10 to the 3rd, a number already given to me in scientific notation, can we convert this back to standard form? So if it was a positive exponent, we want to make this number big. So if we have the number 3.7, you simply just have to take your pencil, put it on the decimal, and move the decimal 3 times. 1, 2, 3. and then I need to fill in those holes with zeros. Those that did that in class did great with this. Those that just tried to sit there and guess without moving the decimal are the ones that struggled. Put your pencil on the decimal mark and move it. So if I had 8.12 times 10 to the second power, and we want to turn this to standard form, put your pencil on the decimal, and we're going to make him bigger 2 times. So moving over twice. Once, twice. So this one I don't need to add any zeros. My answer is 812. Okay. Same thing works true if we had 4.9 times 10 to the negative second power. So if it's -2, we know we got to make the number smaller. So once again, if you just put your pencil on the decimal and move him 2 times to the left, 1, 2. There's your decimal. Fill in the hole for 0. So your new number is 0.049. It's not hard if you put your pencil in decimal and move it. If we had 7.35 times 10 to the -4th, I want you guys to try that one real quick. Okay, so hopefully you wrote 7.35. Put your pencil in decimal, and you said you want to make him smaller, so you moved him 4 times. Once, twice, 3, 4 times. Fill in the holes with zeros, and you should have ended up with 0.000735. There's your final answer. On the test, we are also going to have multiplying and dividing scientific notation. So if we had multiplying 3.4 times 10 to the second, and we want to times that by 1.7 times 10 to the 5th, okay, the quickest way to go do this is we learn how to put this in our calculator. When you type in your calculator, make sure you put your calculator in scientific notation mode. If you do not know how to do that, ask your neighbor or come ask Mr. Haltz. But make sure you put it in scientific notation mode. And then you do not need the parentheses when you type in the multiplying ones. So you type that in your calculator, it gives you the answer, and you're already done. On the test, you will also have division. So if we had 8.4 times 10 to the -2nd, and we want to divide that by 4.1 times 10 to the 5th. Once again, the quickest way to do this is you could just type it right in your calculator. If you don't know, ask your neighbor, ask Mr. Haltz. Okay? The only thing on division is remember you have to, when you put in your calculator, you have to put the problem in the parentheses. If you don't put in the parentheses, you'll make a mistake. Okay? But those are easy points on the test. If you can just put them in your calculator. Once you put in your calculator, it'll give you the answer. Alright, when you're done watching the video, complete the assignment, and then you are finished for the day.